What are the differences in using probes with different attenuation ratios to measure power ripple? Power ripple is the AC component mixed in the output signal of a DC power supply, and its amplitude is usually very small, mostly in the MV or even MV range. Therefore, during testing, it is necessary to minimize interference as much as possible to ensure data accuracy. Due to the weak ripple signal, the long ground wire is prone to introducing external noise. Therefore, the first step is to optimize the grounding method. Unplug the original long ground wire of the oscilloscope and replace it with a grounding spring, or directly use specialized testing fixtures. Connect the test circuit, connect the power supply to the load, and ensure that the power supply is in full power output state simulating actual working scenarios. Ripple data is more informative. Whether using X1 or X10 probes, it is necessary to configure the oscilloscope parameters uniformly before testing to eliminate irrelevant interference. Set as AC coupling, filter the DC component and only allow the ripple AC component to enter the oscilloscope, avoiding the DC signal masking weak ripples. Set to 20 m to avoid high-frequency noise such as spatial electromagnetic interference from entering, and focus on the ripple signal of the power supply itself. Setting the acquisition mode to peak makes it easier to capture the maximum fluctuation range of ripple. When measuring ripple, the two most important parameters we focus on are peak-to-peak value, which reflects the maximum fluctuation amplitude of the ripple, and is the most commonly used indicator, and root mean square value, which reflects the average energy of the ripple. After completing the basic settings, test using X1 and X10 modes respectively. There is a significant difference in the test results. The peak-to-peak value measured using the X1 attenuation probe is 1 mV, with an effective value of approximately 260 microvolts. The peak-to-peak value measured using the X10 attenuation probe is 4.6 mV, with an effective value of approximately 1.6 mV. The core reason for the numerical difference is that the attenuation factor of the probe will synchronously amplify the bottom noise of the oscilloscope. The oscilloscope itself has a basic background noise, small inherent noise. When using an X10 attenuation probe, in order to display a normal amplitude signal on the screen, the oscilloscope will amplify the collected signal including ripple and background noise by 10 times, and the final displayed ripple value is actually real ripple at 10 times background noise, resulting in significantly larger results. The X1 attenuation probe does not require additional signal amplification, and the final displayed ripple value is actually real ripple at 10 times background noise, resulting in significantly larger results. The one attenuation probe does not require additional signal amplification, and there is no additional gain for the bottom noise. The measured values are closer to the true size of the power ripple.